So, hello friends, today we will start the new chapter of our class 10, that is linear equation in two variables. Linear equation in two variables. So, as the name suggests that this equation is actually linear. Linear means, as we have already studied in the polynomial, different type of polynomials we have studied based on the degree, that is linear polynomial, quadratic, biquadratic, cubic polynomial. So in that we have studied that what do you mean by linear polynomial is polynomial having degree 1. So it means in the same way linear equation, if we are talking about linear equation, then linear equation is the equation which is in which the highest power of the variable is 1. That is, degree of that equation is also 1. That's why it is known as the linear equation. And as we are talking about two variables, so definitely it consists of two variables. Like suppose if I take any linear equation, let's say 2x plus 3y plus 6 is equal to 0. So now if you see in this equation that x and y, there are two variables and both is having the highest power 1, so which represents that it is a linear equation. And as there are two variables, that is x and y, so this is actually the linear equation in two variables. So this is known as the linear equation in two variables. So the general form of linear equation in two variables is ax plus by plus c is equal to 0. This is the general form of linear equation in two variables. And in this general form of linear equation in two variables, a is not equal to 0 and b is also not equal to 0. As a and b are the coefficients of x and y respectively. A is the coefficient of x because a is with x and b is the coefficient of y. And this a and b are actually the real numbers. This a, b and c should actually belong to real numbers. So as they belong to real numbers, but so a, b, c can be anything, but a and b cannot be equal to 0, because if any one of these a or either b is 0, then it means, like if I take a is equal to 0, so this equation will become by plus c is equal to 0. As this is a linear equation, but this linear equation is not of two variables, it is of one variable. In the same way, b, if I take b is equal to 0, this equation will be ax plus c is equal to 0. So this equation, linear equation, will get of one variable. So that's why we are saying that a and b cannot be equal to 0. So as they cannot be equal to 0, then always we will get the linear equation in two variables. But it may be the possibility that c can be equal to 0. And if c equal to 0, the equation remains the linear equation of two variables. So there will be no change in the linear equation of two variables. So c can be equal to 0 or it cannot be equal to 0. It means c can be anything, any real number, and a and b also is any real number except 0 for the linear equation in two variables. Now if we talk about the solution of linear equation, then solution of linear equation means that as we are talking about the linear equation, like suppose 2x plus 3y plus 6 is equal to 0, as we are talking about this linear equation. So solution of this linear equation is actually the value of x and y which satisfy this equation. Like if I keep the value of x and y as such like that the summation of these three terms in the LHS side will be equal to 0 of the RHS, then it means that x and y are satisfying this linear equation. And as x and y are satisfying this linear equation, so they becomes the solution of this linear equation. So in this way we'll decide what actually will be the solution of linear equation. So like suppose if I take example, let's say 5x plus y is equal to 13. So and if I keep the value of x and y as 3 and minus 2, it means value of x I will keep as 3, value of y as minus 2. So it will become 5 into 3 minus 2. This is our LHS part. Now if I solve this LHS part, we'll get 15 minus 2, that is 13. So as you are seeing here that LHS is now become equal to the RHS. So it means 3 and minus 2 are the solution of this linear equation because they are satisfying this linear equation. It means LHS will become equal to RHS. So this value of x and y are known as the solution of linear equation. Now, suppose if it is given like suppose same example, if we'll take like 5x plus y is equal to 13. If I need to find how many values are there for x and y which satisfy this linear equation, so accordingly I will get infinite number of values for x and y for which I will get the solution of this linear equation. Like suppose if I take y is equal to 13 minus 5x, as I have taken 5x on the RHS side, so it will become y is equal to 13 minus 5x. So accordingly, whatever will be the value of x I will keep here, I will get the value of y. And that value will definitely satisfy this linear equation, that is 5x plus y is equal to 13. It means if I take x is equal to 0, I will get y is equal to 13. So it means if I keep the value of x0 and y13 in this equation, it is satisfying this linear equation. So it becomes the solution of this linear equation. In the same way, if I keep x is equal to 1, accordingly I will get y is equal to 8. So again, now this is again satisfying this linear equation. So in the same way, I will get infinite number of values for infinite solutions of linear equation. So I will get infinite number of solution for the particular given linear equation. So this is happening, why? Because there is only one equation is given. So if there is only one equation given and there are two variables in the linear equation, so definitely will get infinite number of solutions of that particular linear equation. But if we need to find out the unique solution for the linear equation, then definitely we need to have at least two linear equations if there are two variables in a single equation. So if there are two variables in a single equation, we definitely require minimum of two linear equations to get the unique solution of both the linear equations. Like suppose if I take the simultaneous linear equation like a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So if I take this simultaneous linear equation and if I need to find out the unique solution of this simultaneous linear equation, I can easily get it and get the unique solution, because as there are two variables x and y and I have two linear equations. So as I have two linear equations, definitely I will get two solution of this particular given linear equations. So that is known as the solution of this linear equation, that is value of x and y which are satisfying both this linear equation. This linear equation are known as simultaneous linear equation. So the value of x and y which I get after solving this simultaneous linear equation is actually the solution of both this linear equation, because the value of x and y is actually satisfying both the linear equations simultaneously. So it means it will become the solution of both the linear equations. Like suppose if we take one example based on this, like suppose if the linear equation are given as x plus y is equal to 1 and 2x minus 3y is equal to 7. So if we solve this linear equation, we will get the value of x and y such that it satisfy both the linear equation. Like suppose if I take the value of x as 2 and y as minus 1. So accordingly, if I keep the value of x and y in both the linear equation, it will satisfy both the linear equations simultaneously. Like if I keep the value of x and y in the first equation, that is x plus y is equal to 1, what I will get as, in the LHS part, I will get as x plus y, that is 2 minus 1 is minus 1 and RHS is already 1. So 2 minus 1 I will get as 1 and RHS is already 1. It means it is satisfying this first linear equation. And if I keep the value of x and y in the second linear equation of LHS part of the second linear equation, that is 2x minus 3y. So it will become 2 into 2 minus 3y, that is minus 1. So that is 4 plus 3, 7. And our RHS is already 7. So it means this value of x and y is actually satisfying both the linear equation. So it means this value of x and y is actually the solution of both the linear equations simultaneously. This is known as the So in this way, we'll get the unique solution for the simultaneous linear equation. So it means that we are getting unique solution only in the case when we have two linear equation for two variables. So as there are two variables, so and we require two linear equation for that, that's why we are getting unique solution. But if we have two variables and only one linear equation, we will not get the unique solution. We will get infinite number of solution for the particular given linear equation. Now this linear equation, whatever we are talking about, this linear equation either can be consistent or inconsistent. So linear equation can be either consistent or inconsistent. How we can define that whether the linear equation is consistent or inconsistent? Based on the number of solution that the linear equation have. So like if the linear equation have one solution, or we can say the unique solution or infinite solutions, then we consider that linear equation as the consistent system. But if the linear equation has no solution, it means there is no value of x and y which will satisfy that linear equation. So that linear equation will be said to be as the inconsistent. So it means for the linear equation to be consistent, we require at least one solution for the linear equation. So if we get at least one solution of the linear equation, then that is either unique solution or infinite solution. So that linear equation will consider to be as the consistent. And if we get no solution for the linear equation, then that linear equation will consider to be as the inconsistent. So in this way we'll define whether the linear equation will be the consistent or inconsistent. Now we'll see what will be the methods of solving simultaneous linear equation. It means we'll study about the method of finding out the solution of simultaneous linear equation. So we'll see what is the method of solving those linear equation. So there are actually four methods of solving the linear equation. First method is graphical method, and this method is actually we have already discussed this method in the 9th class, but we'll see some part of this graphical method here also. So first method is our graphical method. Second method is elimination by substitution method. It means we can find out the value of x and y by the substitution method. Third is elimination by equating the and third method is elimination by equating the coefficient. Equating the coefficient means in that we actually need to make the coefficients equal. That's what it actually means, equating the coefficient. And the last method is cross multiplication method. Cross multiplication method. So one by one we'll discuss all this method, and accordingly we'll see how to get the solution of the linear equation by each method. So we'll move on to the first method, that is graphical method. So in the graphical method, what we need to do is, whatever linear equation will be given, we actually need to make the graph of the linear equation. It means we actually need to represent the linear equation in the graphical form. After representing it into the graphical form, what we need to do is we actually then able to find out the solution of the linear equation. Like suppose if I take an example, let's take one example, as if I take two linear equation like 4x minus 5y plus 16 is equal to 0, and second is 2x plus y minus 6 is equal to 0. So as I have got taken these two linear equation, now what I will do first is I will represent these two linear equations graphically, and on the basis of that I will find out the solution of the linear equation. How we can find out on the basis of that, we'll see. First we'll represent this linear equation graphically. So what is the method of representing this linear equation graphically is, like suppose if what I can do is I can take either x in the terms of y or either y in terms of x. Like suppose if I take 4x plus 16 is equal to 5y, or y is equal to 4x plus 16 divided by 5. So accordingly, what I have done is I have taken 5 in terms of x. I have taken y in terms of x. So accordingly, now whatever values I will keep for x, accordingly I will get the values for y, and on the basis of that I will represent this linear equation graphically. So x and y. So now if I take let's take 2 or 3 values of x and y, accordingly I will get the same number of values for y. So suppose if I take x as -4, so if I take an x as -4, so it will become minus 16 plus 16, that is it will become 0. So the value of y accordingly I will get as 0. The same way if I take x as 1, so it will become 4 plus 16, that is 20 divided by 5. So it will become, value of y will become 4. And in the same way if I take x as 6, so it will become 24 plus 16, 40 by 5, that is value of y is 8. So always try to always keep in mind this thing, that take such values of x in for the linear equation in which we will get the integer values of y. So we only need to take those integer values of x for which we will get the integer values of y, because if we get the fractional value of y, it will be difficult to represent graphically. So if we get the integer value of y, it is easier for us to represent this linear equation graphically. So accordingly I will get 3 points, that is -4, 0, 1, 4 and 6, 8. And now I will use this point to represent this linear equation graphically. In the same way, if I take the second equation in the second equation, so accordingly what I can do is in the same way I can either represent x in terms of y or y in terms of x. So if I take it as like y is equal to 6 minus 2x. So accordingly what I can do is, accordingly I can keep the value of x, and in the same way I will get the values of y. So if I take the value of x as let's say 0, I will get the value of y as 6. If I take the value of x, let's say as 2, so I will get the value of y as 2. If I get the value of x as let's say 3, I will get the value of y as 0. Now as I've got 3 values of both the equation, now I will use these values to represent this linear equation graphically. So how we can plot is, as I have already seen in the 9th standard, this is our x-axis, this is our negative x-axis, this is our y-axis, and this is our negative y-axis. Now intersection point of both these axes is origin, that is 0. So accordingly in the for the first equation I will have to represent -4 and 0. So -4 means I have to take the negative x. So this is 1, this is 2, this is 3, and let's say this is 4. So -4 and 0, y is 0. So this is the first point I will get got for the first linear equation, that is -4 and 0. Now the second point is 1 and 4. 1 and 4 is positive 1, that is positive x, and positive y. 1, 2, 3 and 4. So this is the point for the coordinates 1 and 4. So this is the coordinate for the point 1 and 4. And accordingly, if I need to take the third point also, I can also take the third point. But to draw the line, 2 points are sufficient to draw the any linear equation. So now if I join these 2 points, accordingly I will get the graph of this linear equation. In the same way, I will plot the graph of the second linear equation, that is so first point of the second linear equation is x0, y6. So as y is 6, so accordingly I need to take the y as 6, that is this is the point. So this is the point as 0 and 6. Accordingly x2, y2, so this is x2 and this is y2, so this is the point 2, 2. Now if I join these 2 points, so accordingly the intersection point of this two linear equation is actually the solution of both this linear equation, because this is the point which is actually passing from both the linear equation. This is the point which belongs to this linear equation, that is first linear equation, and this is the point which belongs to second linear equation also. So this is the point which is actually satisfying both this linear equation, that is, it's actually the solution for this linear for both the linear equation. And accordingly, as we got the point, now if we draw the perpendicular on the x-axis and accordingly draw the perpendicular on the y-axis. So wherever this perpendicular meet on the x and y axis, accordingly we will get the value of x and y for this point, or accordingly we will get the coordinates of these points, and these coordinates are actually the solution of this linear equation. So now if you see here that this height, so accordingly this height is actually, if you see, it is approximately equal to 4, 1 2 3 4, as accordingly the figure is not up to the mark, but if you draw the proper perpendiculars on the x and y axis, you will get the exact value of this, that is this point. If you take the coordinates of this point, this point is actually intersecting x axis at 1, so it means this x coordinates is 1, and actually it's intersecting y at 4, so it means the coordinates of these points are 1 and 4. So it means solution of both this linear equation is 1 and 4, that is value of x as 1 and value of y as 4. And now if we keep these values of x as 1 and y as 4 in this two linear equation, it will actually satisfy this linear equation. So accordingly, in the same way, we can join in the same way we can plot any two linear equation, and whatever will be the intersection points of those linear equations, that point is actually the solution of both the linear equation. So in this way, graphically we can find out the solution of the linear equations, simultaneous linear equation. So whatever points we'll get, what we need to do is we need to drop the perpendicular on the x and y axis. So wherever they meet the x and y axis, accordingly those points will be taken, that is, this perpendicular is meeting x axis at 1 and this perpendicular is meeting y axis at 4. So it means this 1 and 4 will become the coordinates of this point, or it will become the solution of this both the simultaneous linear equation. Now one more thing we can also get in this type of question is, like suppose, as you can see here, that if we take this point, then accordingly if we taken this linear equation and this linear equation, accordingly we are getting this region which is actually forming the triangle, that is this region is actually the triangle, and accordingly we will get sometimes question to find out the area of this region covered by the triangle. It means like suppose the question if I get as determine the vertices of triangle formed by these lines and x-axis, and also find area. So in this given, it is in this question it is given that what we need to do is that the triangle that is forming with this linear equation is forming the triangle with the x-axis. So accordingly we need to find out the vertices of this triangle, and accordingly we also need to find out the area of the region bounded by this triangle. So what we can do is, as you can see, this triangle is intersecting x-axis at -4 and 0, so it will become the one vertex of the triangle. Second vertex, if you can see here, its second vertex is 1 and 4 because this is the intersection point, and accordingly we can easily see at which point is actually this second line linear equation is intersecting x-axis. So if we can see here, this second point y coordinates are 0, so if we keep the y as 0 in the second linear equation, so we'll get the value of x as 3. So it will become, so it means the vertices of the triangle are -4 0, 1 4 and 3 0. These are the vertices of the triangle. And now if we need to find out the area of the triangle, what we can do is, area is actually, we know that half base into height. So as you can see, height is actually the perpendicular distance from the highest point. So this highest point here is 1 and 4. So coordinates of the highest point are 1 and 4. This is the highest point, and this is the perpendicular distance, that is perpendicular we have dropped on the x-axis, actually the perpendicular distance, that is the height of this triangle. So and accordingly the base is distance of base is from this minus 4 to plus 3. So that means this distance actually will become 7 units. From minus 4 to plus 3, actual distance is 7 units. And height, if you can see, height is from this point to the x-axis is actually 4 units, because y coordinate is 4. So y coordinate is actually representing the distance of this point from x-axis. So it means height will become 4. So accordingly we will keep value here, that is half, base is 7 and height is 4. So if we solve it, what we'll get is 14 square unit. So in this way we can also find out the area of the region bounded by this linear equation with x-axis or with the y-axis, and accordingly we can also find out the vertices. So this is the method of finding out the solution of the simultaneous linear equation by the graphical method.